Good afternoon, everybody. I have to stay right to the desk here, I think, because the room is so crowded. I'm surprised about that. Okay, so I will talk about new materials for metallization and interconnection of perovskite cells. And our focus is on then low temperature processing, which is needed for perovskite, and reducing the silver consumption in metallization and interconnection. So what comes after that rat race for thumbnail cell efficiency records? You want to establish, or the perovskite community must make a transition to large-scale production of modules, maybe tandem modules with efficiency larger than 25% and degradation less than 1% over 25 years. The previous speaker already pointed that out very nicely. And if you want to achieve that, then you will need low temperature metallization and interconnection concepts and materials. Well, these concepts are established in the PV industry, in the silicon cell and module manufacturing. Screen printing is the benchmark because it's so reliable, so robust, and so fast. But for applying ECAs for cell interconnection, you can also use dispensing. And now a new startup, which has a booth here, came up with the idea to use dispensing also for metallization of very fine lines. And regarding the materials, you need conductive particles, conductive fillers embedded in the polymer matrix. The polymer matrix provides the adhesion to the cell and provides the cohesion within the metallization line or interconnection line. And for the metallization, you additionally will need nanoparticles because you want to have sintering to achieve a high conductivity at low temperature. Okay, so this is the outline of my talk. I will introduce to you several concepts for solar cell metallization and interconnection. I will introduce low silver content ECAs for cell interconnection using shingling or the well-established ribbon stringing or ribbon gluing. Then I will introduce to you a new concept called TechConnect and a very recent concept called thermoplastic bus bars. And then in the last part of my talk, I will show what you can achieve in the field of low temperature metallization pastes. And all the materials we have developed at our institute at KIT are based on the phenomenon of capillary suspensions. This is a very generic physical, a very fundamental physical phenomenon which was discovered in our group more than 10 years ago, and it has significant or striking benefits when you want to formulate highly conductive, electrically conductive materials at a low filler content. Let me briefly explain you what capillary suspensions are. They are ternary fluid-solid systems. Usually particles can be suspended in the liquid or in the polymer. When you talk about a polymer composite, and such a binary system may have low viscosity at low filler content. And then you add trace amounts of a secondary fluid. In this case, here in this example, you see how a suspension of calcium carbonate in an organic solvent transitions from a milk-like texture to a cheese or cream-like texture just by adding trace amounts of a secondary fluid, which is water in this case. And if you look at the microstructure, you see the secondary fluid, which is not miscible with the main fluid, sticks to the particles and induces the formation of a particle network. This has a dramatic effect on the texture, as you have seen here in these images, but this applies to all kinds of suspensions of solid particles in two immiscible liquids, and it also works for ECAs, for instance. Here you see when you reduce the filler content, the silver content in an ECA to 48%, you will have a freely flowing, nicely flowing resin system. But if you add a trace amount of a secondary fluid, you change the texture completely. And what happens due to the network formation is that the percolation threshold in the system is shifted drastically. You see that in the graph on the right-hand side, where the conductivity, electrical conductivity, is plotted as a function of particle volume fraction. You see that this strong increase in conductivity